Welcome, everyone, and thanks for coming out this Friday. It's my great pleasure to introduce Jenann Ismael, who is joining us from University of Arizona. She's coming back to Western. She's been in London not so long ago to give a talk, and she's here for an extended visit, and it's been terrific. We've already had a Rotman dialogue in which she talked about some themes from her recent book, How Physics Makes Us Free. And today she'll be talking about some thoughts on time, totality, and transcendence. So please join me in welcoming Jenann.
So thanks so much for having me and for trotting out the winter weather last night. It's lovely to be here, and your building is so nice, so I'm really delighted to sort of see what's become of the Rotman Institute. So this paper is actually, it's connected to some of the themes that are in my book, but a lot of it's very new for me. So these are kind of impressionable thoughts, and I'm deliberately giving them here and sort of building on them in the work in progress seminar, because I know for sure that there's a lot of people here that know more about some of the things I'll be talking about than I do. So please, I should say also, feel free to interrupt. There's nothing here that is going to be derailed by interrupting. So let me see how to do this. So I'm going to start with just some very sort of familiar ideas, but it'll help to set things up. So the problem of fatalism was sort of around long before relativity, but it gained affirmation in many people's minds from the relativistic image of time. So classical fatalism, associated with Parmenides, is a statement about the nature of time. So we have a pre-theoretic view of the world as a spatially extended thing with a fixed past and an open future of branching possibilities. And the claim is that relativity treats time just like the spatial dimensions, and that sense of openness is illusory. Okay? Past, present, and future, it's sometimes said by the people that defend this idea that all exist already according to relativity. There's no good sense in which they remain to be fixed. Okay. So determinism, by contrast, has to do with the physical laws. Again, there were some early versions of it, but it really received a precise and pressing form with the establishment of Newtonian mechanics. When we make a choice, a trivial one or a big one, we make a choice, a trivial one or a big one, it seems to us that the choice makes the difference between two different futures, and that there was nothing set in stone and nothing already in place in advance that determines the outcome. With Newtonian mechanics, of course, it became possible to write down equations that would, in principle, allow one to calculate everything that will happen, including everything that we will do, from a complete specification of the initial conditions of the universe. There are some corrections to those equations that make a difference when we start moving close to the speed of light, and when we start looking at how things move at the very, very small scale, below the Planck scale. But those corrections are fairly well understood, and they don't, as far as we know, except under quite special conditions, make a difference to the movements of things as big and slow as us. Okay. Now, the argument from determinism to the absence of free will, in its simplest and most direct formulation, is known as the consequence argument. So for those of you who know this literature, there are lots of more kind of much more baroque and much more complex formulations. I think the differences between those formulations won't matter to what I say. So I'm just going to stick with the very straightforward version of the argument. And it goes like this. Determinism entails that the laws of nature, together with the past, determine how we will act at any future time. The past is out of our control. Laws of nature are out of control, hence our actions are out of our control. A very simple argument, and beautiful because it's so simple, intractable because it looks so simple. Okay. Now, fatalism and determinism seem on the face of it like different problems. So one has to do with time, specifically with the conception of time associated with relativistic theories, and the other has nothing to do particularly with time, certainly not the specific view of time that relativity introduces. Indeed, it's usually discussed in an entirely pre-relativistic setting, and in fact, I did that mostly in my book. And it has to do with laws which are thought to provide a necessary connection between the state of the world at different times. I now think that there's a connection between these two problems, one that I hadn't seen clearly before. Indeed, that they're both aspects of the very familiar problem of how to reconcile a sort of transcendent vision of the universe, a vision of the universe as it appears from outside of space and time, with the view from within. And that they deepen our sense of what the problem is, while also, I think, suggesting new ways of thinking about it. So that's what I'm going to talk about today. So first, a few remarks about whether, in fact, the sort of four-dimensional image of time associated with relativity, that relativity asks you to adopt, does commit you to fatalism. So when one makes the geometry of space-time part of the proper subject matter of physics, one has to ascend to a sort of form of representation that takes all of space and time, including past, present, and future, into its representational scope. I'm going to call that the transcendent perspective. That's all I mean by the transcendent perspective, or transcendent representation. And it's very difficult to hold in your mind simultaneously a transcendent representation of all of history and the vision of a universe with an open future in the process of coming into being. Okay? So to give imaginative content to the transcendent representation, we tend to lapse into metaphors that embed a low-dimensional representation of the whole four-dimensional manifold in time, usually by suppressing two of the dimensions. And then imagine a sort of godlike creature outside of the manifold, looking down at it, and people are almost irresistibly inclined to say things like that on a four-dimensional representation, the future is already there, that it already exists, and so the idea that there is any genuine contingency is a mistake. But the response to all of this is just to point out that the four-dimensional representation is just what history looks like when time is made endogenous, when it's treated in its internal parameter in your representation. It's a harmless kind of representational transformation that doesn't commit us to thinking the future is there already. In a four-dimensional representation, as I said in sort of the Rotman dialogue, things happen when they happen and at no other time, just as they do in a three-dimensional representation, and just as they do in life. Nor is that transcendent representation or the transcendent perspective literally a point of view from which your future could now be visible to an appropriately situated observer. In the sorts of universes, at least that I'll be talking about, there is no external dimension, and hence no point outside the manifold from which one could even formally construct a point of view. And the now in that phrase, like from which something could now see your future, if it refers to the internal timeline of our world, and what else could it refer to? It doesn't even make sense. Your future is visible from the future for beings that are located in the future and nobody else. Okay. These are all just confusions that come from metaphors that we use when we try to give imaginative content to the transcendent perspective by creating these sort of low-dimensional representations and looking down at them. So we are then adopting ourselves a point of view on these transformations, which is illegitimate if the content is taken seriously. Now what we do is we judge from the perspective of the embedding time, and that's the mistake here. So there are versions of the so-called block universe held by people that do have stronger commitments than this, but the transcendent vision of time that relativistic theories ask you to adopt, I think, does not have the kinds of deep philosophical consequences that people who hold those views allege for free will. It's committed to the fatalistic statement, that is the kind of deflationary view that I'm suggesting relativity asks you to adopt, is committed to the fatalistic statement, what will be, only in a tautologous sense, that it is not the case that what will not be. It's most definitely not committed to the idea that the future is already there, or that there's some fact about the world already in the here and now that necessitates that things will be as they will be. And indeed, that's why to many, myself included, determinism seems like a much stronger and more worrisome problem, precisely because it looks like determinism entails that there are facts in place already, not in the future but in the here and now, that necessitate that things will be as they will be, and it's the physical laws that provide the necessary connection between the present and the future. Okay. Now, when people introduce both of these problems, they often ask us to consider what is true at different times. So they say things like, when they introduce fatalism, it's true today that there will be a sea battle tomorrow, and so it can't be possible today that there isn't a sea battle tomorrow. When they introduce the consequence argument, they say things like, it was true at the beginning of time that the laws were such and such, and that the initial conditions were such and such. And so the future was fixed from the beginning of time because these two things are fixed. In both cases, I think the talk of what's true at different times introduces complications that invite all sorts of confusions. What people are really trying to capture with that vocabulary are questions about what's fixed already or fixed by facts that are already in place. But the vocabulary of truth is not well suited to do that work. It makes no distinction between, it mixes up first order facts and higher order facts. It makes no distinction between intrinsic and relational facts, between facts that are local to the here and now and facts that describe what's happening at other places and times. So I'm not going to speak about what's true at different times. What I am going to talk about, and what I think physics has something to tell us about, is the first order facts that are supposed to form the subject matter of all of this talk about what's true and what's not true. The facts that ultimately, at least from the point of view of physics, ground or provide truth makers for all of the things that we want to say about the world. Okay. I'm going to talk about what happens here at some moment and what happens there at some other moment, and the ways in which what happens here affects what happens over there. Or, to put it in relativistic language, I'm going to talk about how the intrinsic contents of one specified volume of space-time depends on the intrinsic contents of another volume of space-time. Okay. Now, there are two types of dependence. I'm going to suppress a lot of details, but there are two types of dependence broadly that are well defined in physical terms. Merely probabilistic correlation or probabilistic dependence, and the kind of relationship that exists if changes in the contents of one volume of space-time can be used as strategic routes to bringing about changes in another. Okay. That's a little bit stronger than the probabilistic language for reasons that we can talk about if you like, but the basic idea is that the kind of changes that can be used, the kind of changes in one volume of space-time that can be used to bring about changes in another volume of space-time require the notion of an intervention, which is something a little bit stronger than probabilistic dependence. Okay. Now, this latter kind of dependence are what interventionists think of as causal relationships, and they are what most scientists who construct causal models of the phenomena mean. When I talk about, and this is language that I'm going to use, when I talk about the on-the-ground causal order, that's what I'll be referring to. I just mean these sorts of nomologically entailed dependence between the intrinsic contents of one volume of space-time and another. If the causal vocabulary is distracting to you, or you think that these sorts of emergent pathways that get studied in the lab and described by directed acyclic graphs and used by situated agents to bring about ends and so on don't deserve the name of cause because you think the name of cause is something more metaphysically loaded, then just substitute something else in your own mind. I'm just going to use this vocabulary of the on-the-ground causal order to talk about that. Okay. So with these distinctions in hand, we can ask whether the first premise of the consequence argument is indeed true. And it turns out that whether the first premise of the consequence argument is true depends on what you mean by laws of nature, and it depends on what you mean by the past. Okay. So remember what the first premise of the laws of nature are. The first premise of the consequence argument, the first two premises were laws of nature entail that the past is fixed. The future is determined by the past. Okay. So consider a deterministic Newtonian universe. Consider the collection D of events that happen at some early time, and an event that happened at some early time, and an event that occurs at some time later. And heck, let's consider the whole history of the universe up until some specified time t, an event that occurs just a fraction of a second after t. Okay. And ask, according to Newtonian equations of motion, do the events that make up history, the history of the world up until t, nomologically determine the event E? That's just a question of whether there are solutions to the Newtonian equations of motion that include all of the events up until t in which not E happens. Okay. And the answer is, of course, yes. Okay. You just have to add things to the world that are not included in that early world to change the forces impinging on E. It's not the specific collections the specific events in that earlier collection, which according to Newtonian laws determine E, but the totality. And indeed, that's quite general. For any collection of pre-T events, there are models in Newtonian equation of motion that include those events, but which lead to very different futures. In order for a set of events to nomologically determine a future event, according to our best and most familiar and best understood deterministic theory, we have to specify that those events constitute the totality of what there is. Anybody who knows a thing or two about physics will say that, well, we see that works in Newtonian space-time because there's no restriction on which past events might be relevant to some future event. And for reasons related to this, Minkowski space-time, the space-time associated with special relativity, is usually regarded as the most hospitable environment for determinism. Okay? The problem in Newtonian space-time, the thing that seemed to allow different futures for the same past, was that there is no way of explicitly specifying in first-order terms the collection of events that's nomologically sufficient to determine some future event. And in Minkowski space-time, there is. So I don't know if I need to do this, but I'll do it anyways. Okay. So the only spatiotemporal structure in Minkowski space-time is the light cone structure, which separates time into three regions for any point A, like any point A there. The three regions are the absolute past, which contains a set of events that's causally relevant or can be causally relevant to whether or not A. It's absolute future, which contains all of the events, it's the top one there, which can be causally affected by A. And the absolute elsewhere, the white region in which C is located there, that contains all events that are neither causally relevant to nor can be caused by what goes on at A. Okay, so here we've got identified just three different diagrams. There's one on the right, on your left, just indicates points that lie in the causal future. The ones over here includes points that lie in the absolute elsewhere, and the ones here contain points that lie in the absolute past. So here we've got identified points in these three regions, and it turns out that the situation for determinism is actually no better when we consider, in Minkowski space-time, when we consider events that lie even a tiny interval into the future of the present moment. Okay? And we fix events in the absolute past. If E lies at some finite time in the future, then nothing in P's past light cone, so if this is a present moment P, we consider a point in the absolute future, then nothing in P's absolute past suffices to determine whether or not E. Okay? Because of what John Ehrman vividly labeled space invaders, so usually people think of space invaders as intruders from a distant galaxy that come at light speed and intersect one's future light cone. But space invaders is really just a generic name for influences that lie outside one's own absolute past, but are causally relevant to the future. So you can see in these diagrams here that if we consider the light cone of two events, one at t prime and one up there in its causal future, and we consider the light cones of those two events, right? The light cone of this one is going to be nested inside the light cone of that one, leaving always room for events to come outside, from outside the light cone of this one, that are causally relevant to that one, and that's generically true in Minkowski spacetime. So Minkowski spacetime, the laws plus the causal past of here and now do not determine anything that lies at a finite temporal interval in the future. What happens at some future time hinges on what happens between now and then, and in general, given what's already in place, namely fixing the causal past, the absolute past, that can be almost anything. Okay. So using the terminology I'm going to borrow from the cosmologist Raphael Busso, the causal patch of an event, which refers to the set of events that fall within its past causal horizon, does not nomologically determine any event that falls at even a finite temporal interval into its future. Any causal patch in a Minkowski spacetime can be embedded in spacetimes that are solutions to the laws in which different things happen in the future. Things are no better, and indeed famously somewhat worse, for determinism in general relativity. So in the imminent, on-the-ground causal order, any event that falls at even a finite fraction of a second into the future of a point P, even in the most hospitable setting for determinism in Minkowski spacetime, is not fixed by events that fall in P's causal past. And this is not just the epistemic point that a creature in space-time who's confined to knowledge of what's contained in its own causal past, or its own past light cone, is never in a position to use that knowledge to derive or calculate what's going to happen in the future. It's the much more interesting point that there's not enough information contained in its causal past to nomologically fix events at even a fraction of a second into its future. The world itself, so to speak, doesn't know what's going to happen next, given the causal past of any particular moment. Okay. So you might be tempted to say, right, that this really is, after all, an epistemic point for the following reason: the possibility of events that lie outside one's current causal horizon but will become relevant to some future event illustrates that new information is becoming available at every stage of history for a situated agent that was not available before to that agent, even in principle available before to that agent. But you might think, even if I can't know it yet, that stuff is already there. Right? It's already fixed before I start to deliberate about some event in my own causal future, on its way, so to speak, to intersect my future light cone. So that the kind of openness, one might think, that there is for the future, for the inhabitant, that there is of the future for inhabitants of the universe, right, is merely an epistemic openness. Because there's stuff that we don't know about that lies outside our past light cone, but it's on its way to intersect our future light cone. But in thinking that way, people are really trying to impose a conception of the past on Minkowski spacetime that it doesn't really support. You're thinking that there are events that are already there but on their way to intersect my future light cone, but the only meaningful order here is really the causal order embodied in the light cone structure. There's a well-defined order for events that fall in my causal past, a well-defined order for events that fall in my causal future, my future light cone, but no well-defined order relative to the present moment for events that lie in the absolute elsewhere. So there's no objective sense to me made of the idea that that stuff is already there and on its way to intersect my future light cone. In terms of reference frame, there are reference frames in which that stuff happens before the present moment, but there are also reference frames in which it happens after the present moment. Okay. So in Newtonian mechanics, I think we did still have a residual sense in which, even though no open volume of space-time suffices to determine the future, there are facts in place before we act which do. But that's not so in Minkowski spacetime. Okay? And that gives us some insight into the deep consistency, I think, of Minkowski spacetime. Minkowski spacetime gives us a more consistent picture because there's a much tighter connection between the causal structure of the theory and the geometry of spacetime. In general relativity, the local structure is still Minkowskian, and that means that everything that I've said about the fabric of spacetime, I think at the level that matters to human action, carries over to that context. And it's arguable in that setting that at the larger scale there's an even tighter connection between causal structure and geometry. So going back to the first premise now of the consequence argument, if by the past one means the intrinsic contents of some specified volume of spacetime, and by the laws one means the microscopic laws that underlie local processes, it is simply not true that even in Minkowski spacetime, again the most hospitable setting for determinism, because there's a limit that lets us explicitly prescribe the set of events that are causally relevant to some future event, it's still not true that the intrinsic contents of my past light cone determine an event that follows even the tiniest fraction of a second in my causal future. And in general, there just aren't that many nomological connections between the contents of separated volumes of space-time, precisely because it always depends on what happens in between, and as I said, that can be almost anything. We get regularities only when we go, strict regularities, only when we go to the level of totality between global time slices, and only because we've formally turned off contribution from the exogenous factors that keep us from having interesting nomological relations between the contents of separated volumes of space-time inside the universe. Now, when I say we've formally turned off the contribution from exogenous factors, I mean we do it by fiat. We say we're just going to make totality the object of theoretical attention. And then we know that there are no exogenous factors, because that's what totality means. One can see, though, why there's some confusion about this. The Hamiltonian formulation of classical mechanics, some confusion about whether or not and in what sense Newtonian mechanics is deterministic. Because the Hamiltonian formulation represents the state of the universe by a mathematical object, the Hamiltonian, that evolves in accordance with deterministic equations. And these are what most people think of, if they have something specific in mind, when they think of the consequence argument. These laws represent how the universe evolves effectively from a transcendent perspective, because they're explicitly laws that pertain to the universe as a totality. The Hamiltonian represents the total energy of the universe. It's not determined by the intrinsic contents of any finite volume of space-time. This is true, I think, even in a finite universe, because any causal patch drawn from a finite universe can be embedded in a larger universe with a different Hamiltonian. Now, Tim Maudlin refers to the equations of motion that govern the Hamiltonian as fundamental laws of temporal evolution. And this has sort of been taken over in the metaphysics literature. But the notion of fundamental is a little bit tricky here. There are many different kinds of ordering, and what's fundamental in one kind of ordering is not necessarily fundamental in another kind of ordering. If one is interested in the propositions that one would take as fundamental in an axiomatization or systematization of the body of fact, the sorts of things that one would take as first principles and from which one could derive the others, it would make sense to take as fundamental the most wide scope generalizations in an all-encompassing representation of history. The reason that one looks for axiomatizations and systematizations is that they give compact expression to a complex body of fact. And first principles are things that are informationally sufficient to generate the rest. But that's very different from what's fundamental in a kind of stratigraphic structure from the microscopic through the macroscopic up to the large-scale structure of the universe. In this sort of ordering, what we're interested in is the structures that are immanent in space and time. The ordering principle is scale, and the higher levels emerge dynamically from the lower levels. And in that ordering, in a classical setting, the most basic kind of gnomic connections, and the ones that in one way or another, one is inclined to think ground or underwrite the connections at higher levels, are the local microscopic laws that relate the intrinsic contents of some volume of space-time to its immediate environment. The paradigm of these kinds of laws are the laws of classical electromagnetism, Minkowski space-time. In Newtonian mechanics, they're the laws that give the dynamical behavior of an open system as a function of the local forces impinging on it. Those are what sort of guide and constrain events on the ground. And they're what ground whatever form of necessity attaches to the higher order regularities in our classical theories. Now, in the sense of fundamental that looks at this sort of stratigraphic hierarchy of structure immanent in space and time, the microscopic laws that describe the local exchange of a conserved quantity, sort of energy, mass, linear momentum, angular momentum, electric charge, those are more fundamental. The sort of determinism that links global states of the universe at one time to its global state at another, or facts that are in place, for example, shortly after the Big Bang, along some early hypersurface of history to, say, my decision to wear striped socks tomorrow. The sort of determinism that gets people really imaginatively exercised about whether they're really free to act otherwise than they do is not visible from within the universe. Okay? From an immanent perspective, holding fixed the intrinsic contents of one's absolute past and looking into one's future at any temporal remove, there just are many different ways that things could go. Again, global determinism is what you get when you effectively turn off the exogenous influences. It's what you do when you close the universe, or you fix the Hamiltonian, or add the claim that this happens and this happens and this happens, and nothing else. That's the totality of what happens. That totality clause is a strict addition that doesn't follow from any collection of singular positive first-order statements. Okay. So I pointed out that in the intrinsic, on-the-ground causal order described by classical mechanics, special relativity on Minkowski spacetime, or special relativity on Minkowski spacetime, the contents of the past light cone do not determine events at any finite temporal interval into the future. And that's completely compatible with the fact that the Hamiltonian of the universe evolves deterministically. As a formal observation, it shows that in a deterministic setting, adding information about totality is adding something that goes beyond the information about the intrinsic contents of any chosen volume of spacetime and closes off possibilities that are not closed off by the immanent description of the history of the universe. So adding information about totality is effectively adding information in a deterministic context about the future. That information is not available to the creatures in space and time, and is not, moreover, available to act causally on future on events in space-time. And indeed, that's why we don't get the sorts of paradoxes that we would get associated with closed causal loops merely by having determinism. Okay. But how are we supposed to understand this in physical terms? That is, how do we relate these sort of global deterministic laws, the laws that pertain specifically to totalities, and can be represented by deterministic equations that connect the distant past to the long-term future, to immanent structures in space and time? Okay. I think that the right thing to say here is that facts about totality are second-order facts. They contain information about an emergent pattern, but they don't constrain or guide the first order development of the world. Now that observation defangs determinism if one's worry was that determinism meant that there was something already in space-time that physically, causally necessitates a single future. Okay? That's not right. There are all kinds of genuine causal limitations on one's actions. You can't, for example, lift 500 pounds with your pinky. You can't make the clouds go away and the sun appear, become invisible, or travel in time. Each of us has entered into the causal order in such a way that we have limited abilities in a local environment. But among our abilities are things like regulating the impact of the environment on our behavior, making decisions that direct our long-term futures, and so on. What we do and what we decide makes a difference to what happens to us. There's nothing in space and time outside of you, yourself, and your internal struggles when you're making a decision that is nomologically sufficient to fix your future. The global laws describe histories in which it is your internal struggles that put in place facts that are nomologically sufficient to fix your future. Okay. Now, you might not think that this is much consolation. Right? So you might think that what it shows is that the worry was never really that there was something in place in space and time that was causally sufficient to determine your actions. Okay? But that disambiguation of the worry that's supposed to be embodied in determinism, and the connection between determinism and totality, I think does bring the problem of determinism into closer alignment with fatalism, and make them both seem like aspects of the central problem that's always framed the philosophical discussion of time, namely the problem of how to reconcile a transcendent vision of the universe, a vision from which the world appears to evolve deterministically, and an immanent vision of the universe from which one's causal past, or things that are contained in space-time, do not necessitate the future. Both of these are problems that arise when we try to reconcile how our actions look from a transcendent perspective with how we experience them. So just to sort of say a little bit about this contrast between a transcendent representation and immanent one. So transcendent image, as I said, it makes both space and time endogenous, and it brings the whole spatio-temporal manifold into the frame, so to speak, as part of the object of representation. It is, by intent, in the kind of setting that we're talking about here, a representation of totality. An immanent vision of the universe, by contrast, is a vision through the eyes of the embedded participant in history, who experiences the world from different spatio-temporally situated standpoints over the course of her life, and who struggles in response to a bombardment of ever new information to make her life what she wants it to be. The immanent perspective is, of course, the one we occupy. We experience the world from an immanent perspective. The transcendent vision is just a formally constructed representation that, as I said, doesn't literally come with a point of view. Now, I've suggested that at least some of the difficulties with reconciling these two perspectives when I introduced fatalism is the misleading metaphors that we use to try to give imaginative content to the transcendent point of view. And I want to try to give us now, in the remainder of the time here, something a little better than misleading metaphors by suggesting that the right way to think of the relationship between the immanent and the transcendent visions of the universe is as dual descriptions. Now, so there are lots of examples of dual descriptions. Maybe one of the most familiar is the relationship between sort of algebraic and geometric representations of two-dimensional figures. So these are very different looking representations of the same class of objects. Dual descriptions of the kind that I have in mind are, as I'm going to put it, they're compatible, but they're complementary. Okay. You can transform between them. You can transform representations of objects that fall under the scope of these representations. But you shouldn't try to superimpose one on top of the other. And if you do, if you reify in one form of representation structures borrowed from the others, you get redundancies that are apt to look like necessities. I'll say a little bit more about that by thinking of another example. Consider of dual descriptions, okay, one that's especially good for our purposes. So consider a sequence of numbers generated from an initial value by a recursive function. So sequence of numbers is a one-dimensional structure. You can compress it into an initial state, an initial value, and recursive function, or you can accordion it out to the full sequence. These two descriptions, the sort of the compressed description or the full sequence, contain the same information. That's what it means to say that they're dual to one another. Since they're equivalent descriptions of the same, equivalent representations of the same structure, we can relate the structures in one to the structures in the other. So when you give a compressed description, an initial value and a recursive function, what you've done is effectively separated out the common element in the relationship between contiguous elements in a sequence and just written it down once. Now we don't, in the interesting cases, the sequence isn't just first order repetition. We don't have just A. Okay. It's rather that later states are a function of earlier states, so that there's a higher order relationship between contiguous elements. That is the same for any two elements in the sequence. Now, if we give an initial segment of the string when we're looking at the kind of the string of numbers, and we ask whether there are facts in place that is immanent or contained in the initial segment of the sequence that fully determine what function is computed by the string, and hence facts in place in the sequence as soon as the initial value is written down that logically determine its future development. The answer is no. The structure described by the recursive function is sort of spread all over the string. Now there's an epistemic and a metaphysical side to this point. So here's the epistemic point. Suppose that you were given an initial value. There are lots of ways of continuing the string, right? Whether there is a computable or a recursive function that generates it, and what that function is never more certain in advance than the next value in the string. You learn whether there is such a function and what that function is at the same time and at the same speed and in the same increments that you learn what the string is. From a perspective of any location in the string, what function is computed by the whole string is as uncertain as possible continuations of the string. And by possible continuations, I mean just different ways of writing down numbers that continue the string given what's already in place. Now here's the metaphysical side to that point. There's a temptation to think that even if it's correct epistemically, as a metaphysical matter, the continuation of the string is fixed by the initial value and the function that's computed by the string. Okay? So that there's no real contingency at any stage. But the presumption there is that the function is fixed at the initial stage. That is, at the same time that we fix the initial value, or rather that it is fixed at the initial value, because really we don't want to be considering time here. The analog of time is stage in the string. But to say that is to say that the whole string is implicit in the initial value. That is, that the whole string is implicit in the first number of the string, and that's just wrong. Okay? As a mathematical matter, there are many strings that have that value as their initial member. It's simply not the case that the string is fixed as soon as the initial value is written down. So now let's generalize what we said to a four-dimensional manifold. And indeed, just to make things definite, let's generalize it to a four-dimensional manifold with a Minkowski metric. And then let's look at a dual description that generates the whole four-dimensional structure from some curve through it. Now we know in a deterministic context, any Cauchy surface will do. What that tells us is that if the laws of our world are deterministic, there's a dual description that compresses all of the information that the full temporal development of the world, about the full temporal development of the world into a function that generates one state from the next. And does it, moreover, in a way that preserves the full information about the on-the-ground causal order. That is the information that we would get if we described intrinsically the contents of one volume of space-time and its immanent connections to the space around it. It preserves the temporal order, it preserves the local constraints between material contents of one volume of space-time and its environment, it preserves all of the surface causal structure, the ceteris paribus causal connections between the striking of a match and the lighting of a match, all of the causal things, as I said, all of the causal relationships studied in labs and captured in DAGs. It preserves the relationships of control and asymmetries of influence that are part of the macroscopic fabric of the world. It preserves all of the structures that, from a human perspective, makes the sequence of states obtained from that function a temporal one. Now, if we want to relate these two descriptions, the sort of compressed description that takes the Cauchy surface instead of deterministic global laws, and the one that just describes the immanent causal structure, the contents of one volume of space-time and another, and the immanent connections between them, as we did with the recursive function and the sequence, by asking, how do the globally deterministic equations of motion, how are they immanent in the four-dimensional manifold? Where are they in space and time? I think that what we have to say is that they're spread all over the manifold, side to side and back to front. They're not localized anywhere in the manifold. There's something that emerges from all of the locally constrained interactions in space and time, and certainly they don't act on its contents. Now, when he introduces the notion of determinism, Laplace says, for those of you that were there in the dialogue, this was the quote that I mentioned, so I did have it here. Laplace says, an intellect which at a certain moment would know all of the forces that nature set in motion and all of the positions of all of the items of which nature is composed, if this intellect were also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atoms. For such an intellect, nothing would be uncertain, and the future, just like the past, would be present before its eyes. Okay. Now, Laplace says two things here that are exactly right. And it's the same in the French. It's very clear that this was what he intended. He says that the demon, or the intellect, would not just have to know the positions and the momenta of each of the items of which nature is composed. He would have to know all of them to predict its future, and know that it knew all of them. And he says that such an intelligence would embrace in a single formula information about the full temporal development of the world. That Laplacian formula, which is effectively the Hamiltonian of the universe and the law of motion, would have all information about all of history implicit in it. Now, the fact that in a deterministic setting, a complete history of the universe, including your life with all of its internal drama and uncertainty, the anticipation, the surprise, the drama of decision, the regret, the fact that all of that could be written down in a compact form in a way that leaves all of those internal relationships intact doesn't detract from the fact that to make that structure explicit, it needs to be grown. Right? And it grows one stage at a time, with each stage building on the next, and it's not complete till each of those stages is in place, and any two stages have to be mediated by the stages in between. Your life and your struggles are a part of that growth process, and until you make your decisions about what to do, your future is not fixed. From the perspective of the immanent on-the-ground causal order, until you make your decisions, your actions are not fixed. There's nothing other than your internal struggles internal to the world that fixes your decisions. Of course, one can also feel the pull of this sort of transcendent vision, quite aside from the mistaken idea, the idea, who I hope you'll agree isn't right, that there were facts according to a deterministic theory that were in place already, events in your causal past contained in space-time, before you deliberate, that necessitate your future, that determine the outcome of your future decisions. Quite aside from that, determinism still holds some discomfort. It remains true that from a transcendent perspective, one can see one's own life woven into the fabric of a reality that satisfies global deterministic laws of temporal evolution, a reality in which all of the local interactions between this event and that one, between this subsystem and that environment, add up somehow to a deterministic whole. That means that a universe that was in the same total state as ours 14 billion years ago, roughly the age of the observable universe, with all of the particles in the same positions and all of the same momenta, would have eventually, and by just the same root, given rise to you and I, and that we would have all the same experiences and all of the same thoughts and feelings and make all of the same decisions. That feels like necessity, even though it involves no compulsion and no restraint, no constraint. That is, even though the laws that describe that evolution are not literally causal agents that bind your hands or enforce conformity. In a deterministic context, the unfolding of history is making explicit structure that was in some way implicit in the initial conditions and the laws, drawn out by a temporal evolution that generates one stage from the next. You can't bypass that development. And indeed, your own decisions are integral to that development. Because at each stage of it produces information that's used by the next stage. The connection between any two, as I said, passes through the stages in between. And that means the seeds of your decisions are present in the initial conditions of the universe long before you came on the scene. But only the seeds. They're present in the initial conditions in the sense that they are products of those initial conditions by a root that involves your conception, your development, and your growth. Every single one of your experiences, the gradual emergence of your hopes and dreams and fears and convictions. Okay. Now, which is the right perspective? The transcendent or the immanent one? And I think the thing to say is there is no right here. They're demonstrably compatible. They're just different ways of representing one and the same thing. So here's my proposal. I think drop the metaphors of a God's eye point of view. We stop saying things like, according to relativity, the future is already there. We're careful not to reify the global laws as immanent structures in space and time that force us to act one way or another. And we treat these, that is the transcendent and the immanent points of view, as dual descriptions. Or maybe they're triple descriptions. Because what we really have here is three different ways of representing time. Time as you live it, in the world as you live it, time is exogenous. It acts as an external dimension in which each moment is experienced individually as part of an unfolding sequence. In a four-dimensional representation, time is endogenous and represented explicitly as one dimension in a four-dimensional manifold. But time in the Laplacian world formula is implicit. It's implicit in the equation that generates one stage from the next. Okay, that's all I have to say. Sure, great.
Yes. Okay, well, let me use my position as chair to start. So one thing that I was very interested in is whether a lot of the work that's being done and the moves you're making is thinking of open systems and the sort of modal questions that are relevant to them as opposed to closed systems. So that the on-the-ground causal order is partly motivated by the idea that we should think of open systems, where you're asking about how an agent embedded in a system can causally manipulate the systems around them.
Yeah.
Is that really one of the essential?
It's absolutely essential. So the thing is, I mean, the central thing is precisely that there is only one closed system, namely the universe as a whole.
Mm-hmm.
You know? And part of the suggestion here is, so I mean, this is the thing that I'll be talking about in the Work in Progress seminar, which is a question about what that is. Exactly. Certainly it can't be specified in, kind of first order terms in terms of the contents of any given volume of space-time. And part of what I was sort of at least gesturing at here is it's a sort of the notion of the closed system is a kind of formal artifact of just suppressing or turning off the parameter that generates differences in the future.
Yes.
Thank you. I really enjoyed this. I think this is the right way to think about this. I do want to ask about the relationship between different parts of your talk, because there's an awful lot there.
Right.
Most of what you're saying at the end about the trade-off between the transcendent perspective works in basically any kind of space-time structure plus deterministic laws. It doesn't matter if it's a Galilean space-time or Minkowski space-time or what. Then I kind of lost track about why we were talking about the distinction between Galilean and Minkowski space-time. Because most of what you said applies in any space-time that emits of Cauchy surfaces.
Yes. Yeah.
So
the reason was because it looks like maybe one has an answer in Minkowski space-time, right? Because it looks like, at least the initial example was, in Newtonian space-time, no matter how far you go out in space and time, one can add stuff, right? But then so the problem looked like it was one of, there's no way of exhaustively, explicitly specifying the set of events that were causally relevant to some particular event in your future. Right? But of course we have that in Minkowski space-time. So the natural thought that one might have is that this fails in Minkowski space-time.
Okay.
So that's why I'm moving to the Minkowski structure. And also because I think in that setting, the causal structure and the geometry of space-time go together in a nice way that I think is more revealing about what's really going on here.
Does your first argument with the light cone, I would call it that, against determinism, depend on the possibility that causes can be simultaneous? Does that make sense? Because the idea is that you said any event that you are interested in, any finite amount of time after point t, there could be something else that's happened that would change the outcome, and therefore is not determined by the initial light cone. But if any time t, there could be a time slightly before that. Let's just assume time is just continuous. Well, then that's a different light cone already.
Yes, that's exactly right.
And so whatever the smallest time is, if there's always a time before that where that cause happens, but if the cause is temporal,
right.
then,
So
then it looks like
right.
the argument fails unless the cause can be simultaneous.
No. Maybe I missed something in your question. So let me back up and say what I think is true, and then maybe you can. So what's true is first that when we're talking about these relations of nomological determination, right, nothing less when you're considering a point, an event at some point p, nothing less than the events contained in its own causal past will determine it as a matter of nomological necessity. Right? So the question is, well, here I am, and I'm looking into my causal future, and this is specifically why I when I was talking in Minkowski space-time, I always said any event at even a finite temporal interval into your future, because you do need that finite temporal interval in the future. And then the claim is that if what we're interested in, these relations of determination, right, nothing less than its full causal past will suffice to determine it, and that always outruns my causal past. So that's right. So when you say, that causes can be simultaneous, well, if we're looking for the kinds of causes that fully determine the event, right, then nothing less than some cross-section of the path light cone of the event will do. So does that help?
Yes.
So there are a lot of...
I was going to withdraw my question as soon as I finished it, because it just seems, this is new to me, so I'm working it through.
So, I mean, if you're thinking of ordinary, what we think of in ordinary terminology as kind of causal connections between one localized event and another. So those were sort of what I was referring to when I said how we understand those in physical terms. There's a lot of physical substructure that needs to support these sorts of emergent pathways. They're always relativized to choice of a network, and they always have a kind of implicit ceteris paribus clause. You have to hold a lot of other structure fixed to get that kind of local relationship. Right? So those aren't the kinds of things that there's no determination there. There are always ways of defeating those. Right? So the really worrisome ones, and the ones that I think people who worry about determinism, are thinking about, that there's some way of going far back enough that you can catch in the causal net, right, everything that's ever going to be relevant, and that lies in your causal past. And this is just showing very clear, or trying to show that actually that's not what determinism entails. That when you look in detail at the kinds of causal structure there is, the future is as open as events that lie in your absolute elsewhere.
This might be, sorry, I'll go to you next, Bill. Following up on my earlier question, this might be going in a direction that's not helpful, but I was wondering in terms of the sort of transcendent point of view, whether you're tempted to accept something like human supervenience about laws, and whether you would also be tempted to adopt the same position about the on-the-ground causal order.
Good. Okay.
Yeah.
So short answer is no.
Okay.
The short answer is no. So I mean,
no to the second.
No to the humanism.
Okay. No
so this is sort of anathema in some circles, but so I used to be a Humean, right?
Okay. You're a lapsed Humean.
I'm a reformed Humean. But yeah, so the Humeans, what the Humeans think is that laws of nature are just compact descriptions of patterns in the manifold of actual events. Humeans have a much simpler argument against why you shouldn't be worried that there is any such thing as free will, because for the Humeans, what the pattern of events is what determines what the laws are. So you're acting as you do, and this is is part of what determines what the laws are. So the laws don't determine what you do. I mean, there's a very deflationary view. That's so this is an argument for someone who's not, for someone who thinks that when I get into an airplane, there's something else that's keeping the airplane in the air and I can depend on it. And I think that, so it's really, in a way, I'm a Humean about the global laws. So that's why the distinction between the kind of local immanent connections in space and time. I think there are some microscopic necessities that you can treat more like, you don't care that much about my views about laws, but I want to treat those local immanent, kind of laws that describe the kind of degrees of freedom that are open to an electron in it, both in its ordinary behavior and its interaction with other, as real necessities. Right? But the global laws, right, are something that you get by taking a bunch of components and the immanent laws, putting them into interaction. No, they're derivable, right? They're derivable. Put a bunch of particles, given the laws of the particles, into interaction, specify that's all that there is, and derive the global laws for that totality.
So for the real necessities for the on-the-ground causal order, are those more like Cartwright's dispositions or powers, or no?
I feel this.
Sorry, did you want to follow up, Bill?
Well, this was helpful, but I was struck by the way when you talked about the recursive function, and to say that, and of course, if you think that the function is already fixed, then you got the initial condition, then you've got it, and there's your determinism right there. And you, by saying that, look, the function is just, is a property of the whole sequence. So it isn't fixed. That sounds like, I don't want to say Humean, but that sounds like a Lewisian account of laws would be a very natural way to go with that. And of course, the problem with the Lewisian account of laws is it doesn't begin to, in my opinion, do justice to the way we actually use laws in scientific practice. And so I was wondering, some of your answer to Chris helped a little bit, but could you say a little bit more about why your view is open to having the kind of systematic dependency connections that we appeal to and use in doing real science?
So, I'm not sure that I understand. I'm not sure that I understand the question. So just
Okay.
interrupt me and tell me
that's
if I've got it wrong. I mean, there are all kinds of ways. You're absolutely right. In which the Lewisian account is nothing like. It doesn't look anything like the way that laws are used in science. And I meant this to look much more like it. So think about presentations of Newtonian mechanics.
Okay,
So
good.
presentations in Newtonian mechanics, we don't present the law for the universe as a whole. That's the Hamiltonian of a particular universe.
Mhm.
What we write down, here's
Right.
what, here are the components, and here are the laws that govern the components. And if you want to know what the laws are for some particular kind of universe, tell me what it's composed of. And I'll derive the law for that. So of those things that I was calling fundamental laws, those are meant to be the things that you write down when you write down what the components are, the component and the laws that and I'm going to use the terminology of governance. So I mean, I've got no, those to me are the fundamental types of nomological necessity. I'm taking those as basic, and I think that's what happens in science as well.
So the real problem with somebody who buys into the determinism and as a is it's the completeness part.
What do you mean?
I mean, when you're picking,
What I'm saying
to
is
get
that
the Hamiltonian, to say this is the
Yes.
Hamiltonian, that means you've got to say, I've got all of it.
Yeah.
And you're saying we can never do that.
yes,
I'm wondering about, I'm thinking of Laplace,
yeah.
and he's really fixing on the solar system. And
Wait, what?
So-
suppose
What, are you saying in that quotation, he's fixing on the solar system?
I wanted to be able to assume, suppose we assumed that,
How did I lose Laplace?
Yeah, bring the pause back.
I somehow
Okay,
lost
all right,
Laplace.
okay.
No, we're gonna find it. There we go.
okay, you're right, he's saying it more generally,
Yeah.
the whole,
If he just means the solar system, it's not true.
right, that's right, okay. I'm wondering whether,
And he does say, I mean, he doesn't say chacun, he says two.
right,
In
that's,
the
yeah,
French,
yeah, no, that's good. What I'm trying to do is to see if we could find grounds for picking a sufficiently large background that could still give us problems with determinism. And I'm not doing a very good job of trying to figure out a plausible way to do that, but it doesn't seem. But notice, if we had good grounds for assuming that these are all the things that are going to matter,
Yeah, so.
then you would have the problem.
So I have arguments against the possibility of doing that when it comes to, things like, so there's nothing that, this is sort of getting, if you give me a case like that, and you tell me that it fixes my future, I think I can give you an argument.
No, I liked your argument,
Yeah, okay, so then there are interesting questions. I mean, I think the difficult ones that I don't know how to think about, and I mean, that I'll talk about partly, in the way of, in the work in progress thing. So, I mean, as I said, some of these things I don't know what the right thing to say about is, but finite universes. Yeah. Those are really interesting cases, and so I'm not going to talk about them now, but I agree with you. There are interesting questions that are not clearly resolved by what I've said.
Okay, so based on the initial state of the universe, I predict that Jim Brown will have a question.
Oh, how kind of you, and how wrong of you.
Oh no, he's a
But I'll
cat.
force myself. I will rise to the occasion.
The laws will force you.
Well, I'm not sure if this is on target or not, but the thing about the class that I don't like is that it's all epistemic. And if the universe is deterministic or not, that's a metaphysical issue. And this focuses too much on what we can know and what we can't know. And that a lot of worries about determinism and fatalism and so on are really sort of psychologically motivated by epistemic things. What can I know, and and blah blah blah. And I'm not sure if it's relevant at all. I can imagine being told by God, parse cloud, the world's completely deterministic. Here's how I've set it up. Everything has a coin flipper in it, and they'll just randomly move, not randomly, very deterministically move left or right, but based on the coin flip, and you'll never have any control over that or any knowledge of it or whatsoever. Wildly crazy, random world that I feel utterly uncomfortable in, but utterly deterministic. I might even know what the laws are.
Right. So I agree with you completely that much of the discussion of determinism is, it's bathed in epistemic language. This was explicitly, and a couple of times I've tried to emphasize this. The points here are not meant to be epistemic. So a couple of things to say. First of all, if you tell me God could tell you what the future, if I tell you what the future is, then nothing is, right? So that's not worrisome to me. What's true in a deterministic context that looks worrisome is that there are facts about your past that were fixed in advance and that already determine the future, right? And what I'm pointing out here is that there aren't facts that are fixed and in place, irregardless of what people could know. Right? That is, the facts that are in place do not, as a matter of fact, determine. The world doesn't contain enough information. Your past doesn't contain enough information. God Himself, who knew your past and knew the laws, could not predict what happens in the future. You say, yeah, but if God knows about the absolute elsewhere, knowing about the absolute elsewhere is tantamount to knowing about the future. That's the same. You tell me, God, if I tell you what your future is, I can predict your future. It's like, that's why it brings it much more in line with fatalism. The idea that there is some perspective from which that information is available is the fatalistic perspective. Right? Determinism was supposed to be stronger precisely because it was supposed to say that the world contains enough information, facts in place, that already now.
Oh, sorry. Is that right? Is the deterministic ideal says the world contains enough information?
That's my way of putting it.
That sounds very epistemic again.
Well, so I use information so I'll put it in a way. I use information for me is a very basic physical function. But let me put it in ways that don't. Okay. Your past light cone, the contents of your past light cone, the matter and energy contained in your past light cone, together with the laws of nature, do not determine events that happen at a finite temporal interval into your future.
I think Wayne wanted to jump in on
I
this.
just want to make a historical footnote about Laplace. It was really good thing to defend Laplace on this. Everyone quotes this paragraph out of context. He precedes it with a metaphysical statement of determinism. He says, because of the principle of sufficient reason, which he takes to be a priori truth, the present state of the universe determines the future as its cause and is determined by the past that it caused. And then why is he talking now about the knowledge of a hypothetical intellect? Why is he talking about knowledge at all? Well, this is the beginning, opening passages of his philosophical essay on probability. And the point of bringing this hypothetical intellect up is to contrast what it knows with what the maximum of what we could possibly know. Because he's assuming his readers presume determinism, and he's explaining to him, and there's a question in their mind, why is there any such subject as probability in the deterministic universe? And the reason is, we are always infinitely far from the condition of that intellect.
Any other questions or comments? Okay, well, we would.
Yeah, a tiny one, because it's a little follow-up, because it's in the Laplacian spirit, but with information in your sense. There's, you know, the Pourel and Richard stuff on computability in classical physics. Oh, yeah. Then it's. I'll say one sentence and just drop another. There are these systems where you've got all the information, initial conditions, and the subsequent history is not computable.
Right.
Yeah. So I was thinking that might be an interesting.
There's I mean, there's lots of ways in which determinism looks less interesting. So this was meant to be like, the most well understood, easiest kind of, deterministic looking universe. So yeah, I agree. There's one way to put it, to kind of gesture the direction in which I think it's natural to think is, so the really interesting questions are, what are the sources of novelty, right? And one of them can be, the exogenous factors coming in, but I also think, that the laws themselves are productive in a way that makes, the future look unpredictable.
Yeah.
Great. Well, I think we should all be grateful for recovering from fatalism and getting back to